My name is Prem De Cruz, and I'm an IBM thought leader. Today, I am going to walk you through an IBM Internet of Things Visual Insights demo, which is run as a SaaS application. This application helps manufacturers to detect quality issues using deep learning and AI. So what you see in the screen in front of you are the images that are being used to train the model. These images have been collected through a camera that actually takes these shots as the part is leaving the assembly line. And this reduces the time for someone to manually inspect the parts for quality. Now, there are three types of parts. You have the good parts here that we're looking at. I'm going to open one of these here and zoom into it. And you see that the red tab is perfect on this part. And you also see 6 pins out here that are perfect. So these are the good parts. If you look at the missing tab, a directory, and I expand this part here, this part really has the tab that is missing. So this tab is missing here, and it's a defect. It's a defective part, and we need to remove it. And if you look at the bent pin directory here, I open this part here and zoom into it. You can see that one of the 6 pins is bent and not showing up. And these are very hard to detect manually, but a Visual Insights program with machine learning helps you to detect it automatically and in a shorter time, thereby improving your productivity. I am now going to walk you through how you log into a SaaS application and show you the ease of use. All you need is a web browser, and you need to be able to open the application with your credentials. I am now in the IBM Visual Insights program. I am going to pick models because I want to go and build a machine learning model. I have already ingested all the data to save time. It takes time to upload the data. So what I have done is all the data files have been uploaded. We have the bent pin images, the missing tab images, we have the good images, we have the validation images also. So validation is used to validate the model after it has been trained, and we'll go through it. So the way that you ingest the data is you click on new image group. It's a labeled image group. You type in a name for the image group as I did, and you pick the characteristic here. So single characteristic means one defect, multiple means more than one, and not a defect means good. And you type in next, and then the next prompt is to upload the file, which is a zip file, and it takes about 3 or 4 minutes to upload about 100 images that you saw there. So I'm just going to close this here. And since the data has been uploaded, let's create a new model here. Create a new model here. I give it a name. And I give it a product type, which we have to remember because we will need it later on, you'll see. I hit next here. So these are the options. So I'm going to pick here on customized here, and there are different algorithms too. So I am going to pick LeanNet here as the algorithm, and I'm going to take all the other default parameters. You can read the documentation to see how what the default parameters mean. So let me verify. I believe it's still on LeanNet, and I'll say next here. So it says to select from imaging sets. So I want to train the model on 3 imaging sets. So good, missing tab, and bent pin. So those are the 3 models I am going to use, or the 3 data sets, and I'm going to say next. So these are some other options we have but we'll take the default values here. So it's confirming everything for me. Here it says what my model name is, product name, LeanNet, all the default values here. You know how many images I have also. I have 295 for good, 95 for missing, and 95 for bent pin. And I'm going to say train. So right now the model is training. You can see here is the status that it actually gives you. And so as the model is training, I will go through a few things about the benefits of this application. It takes about 2 or 3 minutes for the model to train. So really, we are using machine learning and AI to train a model so it can recognize defects. If we catch defects in the production stage, the cost is much cheaper, because if it is at the field stage, we are going to have warranty problems, and sometimes we can have expensive recalls. The UI for this product is very simple to use. It's user-friendly. It does not require a data scientist. All you need is someone who has strong domain experience. And the IBM Visual Insights program does not tire like a human being tires, and there's no mental fatigue. It is always alert. There are no chances of errors also. All you need to do is you need to upload a good sample of good images and defective images, and the algorithms and the software, there are 3 of them. They train the model, and once the model is trained, I'll show you how it can self-train itself also. So it improves over time. The models improve over time also. There's a Chinese manufacturer who makes LCD panels, and they have 100 workers in their quality assurance department. It takes them 30 minutes to train a model, but with the help of Visual Insights, they have reduced that 30 minutes to 5 minutes. And because they've reduced it to 5 minutes, it has really improved their productivity. And what they can do is they can reduce the entire manufacturing cycle by up to 1 day, which is really very, very, it's a very, very good thing for them. So it keeps telling me the status here, that my model is being trained here. As soon as the training's over, and here it gives me the time, the amount of time it takes to train the model here. So we can see how much of time it takes the model here to train. So it's already 2 minutes and 43 seconds. So I had a lot of empty time to fill up here. So that is why. So now it is trained. It took 2 minutes and 43 seconds. It says trained. This model is ready for validation by a model manager. After the model is validated, it can be deployed. So there are 3 steps that we have to go through. We have to go through the training, then we need to go through the validation, and we need to go through the deployment of the model. So I'm going to see the options here. I'm going to scroll down here. So it tells me what the test accuracy is, 83.569%. We can change this accuracy by actually uploading new models. We can do that also. So I am going to now go and click on validate the model. So I have to pick the validation sets here. So the validation sets are already here. So I'm going to pick, this is my validation set for good. I'm going to expand this here. This is the validation set for missing tab. And for bent pin, I am going to pick the validation here. So I have the 3 validation files picked for the 3 classes of images I have. Now, these validation files have not been used by the program. So this is the test. We are putting our model to the test, and we are going to see how good the results are after we have trained the model. So I am going to click on validate here. The validation here is taking place. So while the validation is taking place here, I will, so the status on the training dashboard, this is the training dashboard we have here. So it says that the validation is taking place and it's validating. So it has validated. The validation results here are 96.66%. I am going to view the report, and these are very good validation results that I've got. So really, there were 10 good images. All were classified as good. There were 10 missing tab images here. All were classified as missing tab. So bent pin, it only picked up 9 as bent pins, and then 1 of the bent pin images was classified as good. So that's an error. So basically the accuracy here is 96.66%, which is excellent. If it had classified this as a bent pin, my validation results would have been 100%. So so it's done a pretty good job with this. And so since I like the model, I'm going to accept and publish it here. Now the model is accepted and publishing. The next step after this is to score the model, and we will work on that too shortly once it's accepted. So my model has been deployed here. You can see the images here. Now we are going to go and score the model. So for that, I go into API guidance here, and and I want to register my model. So I've registered the model. I want to deploy the model and I want to test the model. Now I am going to type in the product type here. And that is why the product type was very important. I said we need to remember it. And I'm going to select a random image to actually go and test the model. So I'll do select here, and let me go to an image that it has not seen before. I'm going to pick this image here. It looks like a defective image. It has not seen it before. So I picked it here, and this is why the product type is very important. And I'm going to say score. So you can see the result column is pending here. So it's going to score the model here. So it has scored the model. So it's a little, so 63.97% confidence level, it thinks it's a missing tab. 25.34 is good. And then 10.7 is the bent pin. So, and it's in plant 1, line 1, cell 1. So, so this is how we take real models here. So really, as the parts are going through the production line, the camera will click a shot of the part, and then the program will test it against the trained model that we have validated and deployed to, and then will tell us what the results are. So the operator can automatically decide if they want the part to move on, or they want to actually pull the part out for a manual inspection. In this case, since the confidence level isn't very high, it'll be pulled off the production line to be checked actually to actually ensure that it truly has a missing tab. And in that case, the part will be removed off the assembly line. Now, how do you go and self-train the model here? So let me go back here to the screen here, and I am going to click on workstations here. So I'll click on one of these images that's been confirmed here. So under the Cruise 2, this is the image that I have. So this is the model that I have here. So I'm going to view it. So this is the part that we saw that was defective here, and the missing tab is indeed there. So so I think we can verify it. And now this is how we retrain the model. So we can click on this eye icon here, and then if it is not a missing tab, if it was a good part, or if it was a bent pin, we could click on one of these icons here, and then we could retrain the model. So automatically the model is self-learning and it is retrained on the fly. So if, for example, if I pick bent pin, if it was a bent pin here, and if I say confirm, it would automatically go and would retrain the model. And then this image would be classified as a bent pin problem or an unknown defect too. It could be one of the other two here. And then I need to confirm it. So this is how we use IoT to actually help us improve our efficiency. IoT has many solutions. We have the visual and the acoustic inspection solution. The acoustic inspection solution is based on sounds. So, for example, if you're testing washing machines, based on the sound of the washing machine, we can train it to actually detect what the problem is, whether it's a shaft failure or a bearing failure. Then we have prescriptive quality on the cloud. We have prescriptive maintenance on the cloud. We have Maximo Asset Health Insights that can give you insights into your assets stored in Maximo. We already talked about visual insights, which are deep learning classification models. We have production optimization. We have equipment maintenance advisor, and we have PMO. So really, if you really want to understand more about IBM products in the Internet of Things space, please reach out to us, and we would be very, very happy to help you out. Thank you so much for your time.